This lesson is rotation of axis of conics. Okay, so rotation of axis for conics. You have two different forms, the first and the second. The difference between the first and the second is that the first does not have a b term. The second has a b term. So if you have equation that does not have a b term, then you will use the first one. Okay, all you have to do is just take a times c, whatever the number is, equals 0, parabola, greater than 0, ellipse, circle, less than 0, hyperbola. However, if you have equation with a b term always have x and y together. That's the b term, always have x and y together. Okay, so if you have a b term, then you must use b squared minus 4ac. Okay, and this formula right here, b squared minus 4ac, is from the quadratic formula under the square root. If you remember quadratic formula, this is from the quadratic formula under the square root. Okay, so same procedure, just plug these numbers in, a, b, c, equals 0, parabola, less than 0, ellipse or circle, greater than 0, hyperbola. Okay, so one more time. Two different ways to identify a conics. However, the first form, if you do not have a b, then you use this method. If you have a b term, you have to use this method. Okay, but for our lesson, we're going to focus on the second term. We're going to focus on this guy right here. Okay, so here's our example. Here's your A, B, C, D, E, F. Again, B always have x and y together. So b squared minus 4ac, b is 3, 4, a is 1, c, negative 2. Okay, order of operation, that gives me 9 plus 8, 9 plus 8, 17. 17 is bigger than 0, so it is a hyperbola. This is how you identify this equation as a hyperbola. Okay, there is a longer process of this. There is much longer process, but this is the short version of this, the easiest version. Okay, but there is a longer process of this. Okay, all right, so this is how you identify a conics. Is it hyperbola, parabola, or a ellipse or circle? Okay, so make sure, again, back to this. Okay, all right, we're using the same example, but this time we need to find the angle. We need to find the degree of rotation. What degree it has been, okay, we need to find the degree of rotation. How much did it rotate? Okay, so same example, but I'm going to give you two options, option 1 and option 2. Option 1 is cotangent to theta AC, A minus C over B. So we know what A is, we know what B is, we know what C is, so just plug it in. So that gives me positive 3, because negative and negative is 2, positive 2, 2 plus 1 gives me 3. And then over 3, 3 over 3 gives me 1. Okay, so cotangent to theta equal 1. Now bring cotangent to the right side, that gives me inverse cotangent. Okay, now if you have a very advanced graphing scientific calculator, then you do have this function on your calculator. So all you have to do is look for this function, type it in, cotangent, inverse cotangent of 1 will give me 45 degrees. Okay, and then there's a 2 here, so I want theta to be by itself, so divide by 2 gives me 22.5. Again, option 1, if you have a very advanced calculator that has cotangent and the inverse of cotangent. However, some of us do not have a scientific calculator that give us cotangent inverse. We don't have this. Some of us do not have this cotangent inverse button on your calculator. So what do? That's why we have option 2. So if you look very carefully, the only difference is that this is cotangent, this is tangent, and A minus CB, all it did is just get flipped. It just flipped, okay? Just flip it, okay? So same procedure, put B in, which is 3, right here. B is 3, A is 1, C is negative 2. So same thing, 1, Negative and negative, positive 2. So 1 plus 2 gives me 3. 3 divided by 3 gives me 1. So tangent to theta equal 1. Bring the tangent to the right-hand side, tangent inverse. You do have this on your calculator. So if you have one of these calculator, okay, tangent inverse is right here. Here's tangent inverse right there. Okay, again, if you have this kind of calculator, or if you're using your calculator on the phone, make sure you turn the phone sideways. Okay, turn your phone sideways so that you can see sine, cosine, tangent. Okay, so if you're using your phone calculator, turn it sideways. Okay, so all you have to do is just put tangent inverse. So second is tangent. Okay, right there, tan negative 1. Okay, to the negative 1 power. Now, if you were using your phone, then right here it should say a tangent. If you are using your phone, the calculator on your phone, it should say a tangent, which is the same thing. Okay, so put 1 in. Okay, and then all you have to do is, now again, if you don't have to put the close parenthesis, it's the same thing. Okay, you don't have to. Okay, equals, so there's the 45, 45. Okay, 45, 45. Okay, so that's how you use your calculator, a regular calculator. Again, some calculator do not have this function, cotangent inverse. Some calculator do not have that. So that's why we use option 2, because we have tangent. Okay. And then again, we want theta to be by itself, so divide 2 over 22.5. Okay. So here I put a note, use option 2 because some scientific calculator do not have inverse cotangent. Okay. So let me zoom out so that you can see the difference between option 1 and option 2. Okay. So on the left side is cotangent, on the right side is tangent. If you have a very advanced calculator, you should have cotangent inverse in your calculator. Okay, if you're using a regular scientific calculator, then use this one. But in my opinion, some of us do not have the cotangent inverse. So use option 2. Okay, use option 2. Okay, all right. So I'm going to make a note of this. If you are using cotangent, okay, note. I have it right here. Note, if you are using option 1, okay, the range of cotangent, inverse cotangent is from 0 to 180. The range of inverse cotangent is from 0 to 180. So if you have two options, you have two cases. Case number 1, if your angle is already positive, you leave it alone, divide by 2, which is 22.5. This right here is the same as what I have here. Okay, so what does this mean? That means that your axis has been rotated at 22.5 degrees. It has been rotated just like this. It's been rotated. Okay, so again, if you are using option number 1, you have to be very careful that the inverse cotangent, the range is from 0 to 180. And you have two cases. If your angle is positive, like right here, which I have here, 45, 45. Okay, I'm using the same example, but I'm just making a note. If your angle is positive, leave it alone. Divide by 2. This is the angle that will be rotated. Okay, that your axis will be rotated at 22.5. Okay. However, if your angle is negative, again, I'm just making up this number. This number, I'm just making it up. Okay. But if it's negative, you must subtract from 180. Why 180? Because your range is from 0 to 180. Okay. So again, if your angle is negative, you must subtract from 180, which gives me 135, and then divide by 2. This angle, 67.5, is the actual angle that we need where the axis has been rotated. So here's my axis, rotate, 67.5. Okay, so be very careful if you are using option number 1, which is cotangent. The inverse of cotangent is 0 to 180. Okay, so be very careful. If it's positive, leave it alone, divide by 2. If it's negative, subtract from 180, divide by 2. And subtract 180 first, whatever you get, then divide it by 2. This is the actual angle that we need when it got rotate. Okay? So be very careful of that. Now, I want to make a note of option 2. Okay, this, let me zoom out, is option number 1. But I need to make a note of option 2 because most of us will use tangent. Okay, so same thing. Okay, for note for option 2, when we use option 2, the range of inverse tangent is from negative 90 to positive 90. Okay, the range of inverse tangent is from negative 90 to positive 90. So same thing. If your angle is already positive, you have two cases. If your range is already positive, leave it alone, divide by 2, which is the same answer as over here. Same answer. Okay? However, if your angle is negative in tangent, you must change it to positive, divide by 2, and then take this number right here, 22.5, 90, subtract 22.5. Why 90? Because your range is from negative 90 to positive 90. Okay, so be very careful when you use option number 2. Okay, so if your angle is negative, change it to positive, divide by 2, subtract 90. Okay, 90 subtract after you divide by 2. Okay, so 90 subtract this number after divide by 2. This is the answer that we need. The rotation of axis. Okay, the degree rotation of axis, 67.5. So if you look very carefully, and I will put this side by side, it is the same thing. So this is the same as this. This is the same as this. The only difference is that this if you are using cotangent. This if you are using inverse tangent. Okay, okay, so be very careful of that. Let me zoom out. Okay, I hope you can see the whole thing. Okay, so one more time. On the left, right here, if you are using option number 1 with inverse cotangent, on this side, it is option number 2 for inverse tangent. And I did specifically say that we will use option number 2, and the reason is because most calculators do not have inverse cotangent. Okay, but if you do have inverse cotangent in your calculator, then you use option number 1. But most of us will use option number 2 because we do not have cotangent inverse in our calculator. Okay, so be very, very careful, and I hope this helps out side by side. Okay, side by side. Okay. Now, I want to make an extension of option number 1, a note extension of number 1. Okay, so note extension of option number 1 algebraically. Solve this by hand. So I'm going to use the same example right here. Same example, cotangent 2 theta equal 1. Same thing here. All right, cotangent theta equal 1. I'm just going to ignore the 2 for now. I'm going to ignore the 2. Okay, just ignore the 2 for now. Okay, so I'm going to solve this. I'm going to solve option number 1 by algebraically. Okay, so where did I get this from? Over here. I just ignored the 2. Okay, if you look carefully, this same. I just ignored the 2. Okay, so I'm going to solve option number 1 algebraically by hand. Okay, so we know that cotangent, we know that the ratio identity for cotangent is 1 over tangent. Okay, ratio identity of cotangent is 1 over tangent. Bring the tangent to the right, which I have here. Bring down the 1 by divide. Bring down the 1 by divide. 1 divided by 1 is 1. Okay, and then bring the tangent back to the left side. So we inverse it. Use your calculator. Tangent inverse of 1 gives me 45 degrees. Okay, and since our angle is positive, just divide by 2. Since our angle is positive, just divide by 2. Okay, so that's what we have here. So if our angle is positive, we divide by 2. So it gives me 22.5. This is the same answer as this over here. Okay, algebraically. This right here, what I'm circling, if you have a calculator, you just put it in your calculator. But what if you want to do this algebraically? Algebraically. Okay, so that's what you will do. Okay, let me zoom out so that you can see the algebraically from the top all the way to the end. Okay, now what is this on the right hand side? This is just another example. This is just another example. What if this number right here where I am circling is not a nice number? You get this kind of crazy number. If it's not a nice number, what do you do when it is not a nice number? So again, just pretend. Okay, so this is a nice number. This right here is not a nice number. So how do I do this? So just basic order of operations, square root of 3, which is 1.7320. 1 divided by it gives me 0.5773. Don't forget the negative. Same thing here. What is the ratio identity of cotangent? Ratio identity of cotangent is 1 over tangent. Bring the tangent to the right side. Bring the 5.73 down. Bring this tangent to the right. Bring 0.5773 down. Divide. 1 divided by 0.5773 gives me negative 1.7322. Okay? Again, don't forget that negative because we want to bring it over. We want tangent to be positive, so bring the whole thing over. Okay? And then now bring the tangent back to the left, which is the inverse. Okay? So put this number in your calculator. Okay? So like what I have here. So I'm going to show you. So second. Okay? So second tangent. There it is. Okay? Right there. And then put that number in. So again, in your calculator, you have 2 buttons. This button is for subtract. This button is for negative. Subtract, negative. So be very careful. Do not use this button for negative. This is for negative. Negative 1.7322. You can close it if you want, not necessary. And then press equal. And there it is. 60.002, which is what I have here. Okay, so I kind of, yep, 60.0021 right there. Okay, all right. Now, however, we are in cotangent. We are in cotangent. Okay, so just like what I show you in option number 1. In option number 1, if your angle is negative, you must subtract from 180. Okay, that was from option number 1. Okay, which I have it right here, option number 1. So option number 1, why? Because we are in cotangent. So we will take this number because it's negative. 180, subtract that number gives me this. We'll just round this to 120. So technically, cotangent 2 theta negative 1 over square root 3 is 120. Again, where did this 2 come from? It's supposed to be up here. I just ignore it because I don't want that 2 right here to be distracting. I don't want this 2 to be right here because it's distracting. So that's why I ignored it. Okay? And then divide by 2. So cotangent 2 theta equal negative 1 radical 3, which what I have up here. Which exactly what I have up here. Now, why is there no 2 here? I just ignore it. I don't want that, the 2, I don't want to put the 2 here. It becomes very distracting. Okay? So that's why I ignored it. So technically this is this. Okay, again, this is this, which comes out to be 120 degrees. However, I have a 2 in here. I have to divide by 2. Why divide by 2? Because this is a 2. Okay, so technically, this is the angle that we need for the axis of rotation at 60 degrees. Okay, so again, what is the difference between the right and the left? The only difference is that it's a different number, just a different value, but the same procedure algebraically, for option 1. Let me find that option. Here it is, option 1, right there. Okay, again, this page right here is the extension. Is the extension of option number 1 over here algebraically. Okay, what if I want to do this right here, option number 1, by hand or algebraically? Okay, so be very careful. And then on the left hand side, if when you have a nice number, what if you have a very scary number like that? What do we do? So it's just basic algebra. Okay, just basic order of algebra. Okay, so again, this page is option number 1, and I want to extend this option number 1 algebraically. What if I don't have this in my calculator? How do I do option number 1 algebraically by hand? Okay, the one on the left is the example here. The one on the left is the example. Okay, the one on the, this is the left, this is the example of option number 1. The one on the right, I'm just making another example. What if I don't get a nice number? Okay, what if I don't get a nice number? This is a nice number, this is not a nice number. What do I do when I have something like this? So it's the basic algebra, okay? Just basic order of algebra. So let me zoom out so you can see the whole thing. Okay. Again, this is the extension of option number 1 over here algebraically. Okay, algebraically extension from number 1, option number 1. Okay, so be very, very careful. Okay. All right, and then the last page. We want to rewrite this. We want to rewrite this into this form. We want to write the original into this form. Now we're going to skip this because it's very lengthy process. The process is very lengthy, okay? But I'm just going to give it out so that you, just in case if you need this in future classes. Okay, so let me zoom out. Again, how do I rewrite the original equation into this form? Okay, this is the original, this is the new. How do I rewrite this into this? Well, we're going to use these formulas. We're going to use this formula plus the angle, either cotangent or tangent. Either one still works. Okay, it's the same. Okay, so, but we're going to skip this section is because the process is very lengthy. The process of going through this is very lengthy. So we're going to skip this portion. Okay, but I still show it to you just in case you might need this for future reference. Okay. Right. So our main focus today, of today's class lesson is this. This is our main focus. And when you do your homework, I just want these two. One, identify the conics, what kind of conic it is. Number two, find the angle of rotations. Okay, so that's our main focus for this lesson. And same thing with your homework. Just focus on these two. 1, 2. Just focus on these two. 1, identify the conics. 2, find the degree of rotations. Okay, that's all I want for this lesson. Okay, to focus on identifying the conics, find the degree of rotations. Now be very careful. If you're using option 1, be very careful of option 1. Be very careful also option 2. And I did make a note of option 1 and option 2. So before I show that again, the lesson for today, okay, is just to focus on identifying the conics and finding the degree of rotation. That's the only two focus I want for today's lesson. Okay, identify the conics, find the degree of rotation. Okay, and then let me put side by side of the extension. Okay, side by side of the extension of option 1 and option 2. I want to put side by side of option 1 and option 2. So be very careful of that as well too. And I hope you can see this. Okay. Again, on the left will be option 1 if you're using cotangent inverse. On the right if you're using tangent inverse. And I sort of kind of push you to option 2 because most of us do not have a calculator that have cotangent inverse. Okay, so be very careful of that. Now this page right here is the algebra, is by hand how to do option number 1. So let me go back to that page, option number 1. So this right here, this page is the extension of option number 1 over here. But how do I do it by hand, algebraically? Okay, so let me zoom that out so you can see the whole thing. Okay, and then the last page, this is just for future reference, just in case you are required to change the original into a new form. This is original, this is the new form. Okay, and the process is very lengthy. As you can see, a lot of formula. You got 1, 2, 3, 4, 5, 6 formula that you have to deal with. This process is very lengthy. Okay, so that's for future reference. Okay, so I hope this helps out. Okay, so again, our main focus today's lesson is just on these two. Just on these two. Identify the conics and finding the degree of rotations. Okay, those are the two main focus we're going to do for this lesson. Okay, so let me zoom. Okay, there it is. Okay.